he calls, he says there is an whenever you make a reaction undergoes, it will be either endo or exo. Then he talks why this happens. So exo is heat is given out, heat is given out, heat is given out. Now, how do you know heat is given out? You have a reaction, you put it in a test tube, you mix two things, you have a thermometer here, and you find that the temperature is rising. Why is the temperature rising? Because the reaction proceeded. CH4, let's say methane is reacting with O2 to give you CO2 and H2O, and heat is given out. So heat is given out and it goes to the surrounding. So this is the system. This is the system. This gives out the heat and the surrounding takes the heat. Now, what is the surrounding? The surrounding could be a test tube, it could be air around it, it could be if the reaction is being done in water, soluble, मतलब कि both of them dissolved in water, it could be water. All it could be the thermometer which itself is taking the heat. All these take the heat. And who gives the heat? This. But why do this give the heat? Because there are chemical bonds inside which are getting broken. And they have bond energies. And that results in the change, the energy change. Just read this as energy change. Enthalpy, I will explain later. So so I start again. It's like this. Exo, heat is given out, temperature rises. Who takes the heat? The surrounding. Who's giving the heat? The chemicals when they are reacting. And the surrounding, the test tube, the thermometer, all of them take the heat, and that's why the mercury in the thermometer rises, and even the water takes the heat. So if you are holding it, your hand, you will feel the heat. You will feel the heat has come out of the reaction. Your body is taking in the heat. You're holding the test tube, your body is taking the heat. You are also the surrounding. Now, endothermic, the opposite happens. So he gives you this reaction, and this is he says you got barium hydroxide and ammonium chloride, and the temperature falls so sharply that the water under the breaker will freeze. So what is happening? You got a case where you have barium hydroxide reacting with ammonium chloride, and you'll get BaCl2 and NH4OH. And what happens is this they take in the heat. The 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 system will take in the heat. Now, if it takes in the heat, if it's on a beaker and there's water around, so the water gives the heat, the air gives the heat. If you're holding with your hand, your body gives the heat. Why does it give the heat? Because the bond energies require heat. The new bonds being formed require more energy. So they will extract the energy from wherever they can. And that is why this is an endothermic reaction. So the endothermic is it is extracting, opposite is happening. The BaCl2, BaOH hydroxide plus NH4Cl Cl is reacting to form BaCl2, something new which is going to require where the bond energies are higher, so require energy. So they take in energy from the surrounding, they take in energy from the surrounding. And who gives the test tube is giving, the air is giving, the water is giving, everything freezes, their hand is giving, they require. Okay, now, so there are many types of reactions. Like if a combustion is basically an exothermic, there are some reactions like neutralization is also exothermic. Some reactions are endothermic, which require an energy. But how do you indicate all this? You indicate all this by writing, by drawing either a energy level diagram. This is where this is an exothermic reaction, like CH4 methane reacting with O2 to give you CO2 and H2O. Now, what do you see out of this? You see the products are here. This is CO2 plus H2. What do you get here? You have got CH4 plus O2. The reactants, the products. What? There's a hump in between. What has happened here? You see, what has happened is these bonds have to be broken. So we have got this here. This is methane, and we have got double bond O. And then what do we have here? We have CO2. Now this is CO2, and we have H2O. This is H2O. So the bonds have these bonds have to be formed, and these bonds have to be first broken. So they break. They break. All bonds break, and this goes into an atomic state. Everything converts into atoms. So it's not so straightforward, but this will have H, C, 4H will come here, and this breaking is making it go higher up. And then after they have broken, all of them are separate, they will join again and fall down. So the here bond breaking is happening. Bond breaking is happening. And here bond forming is happening. Now within the reaction also, this bond forming is a lower going lower. It's an exothermic reaction, and this is breaking. It requires energy, and this is an endothermic. Within a reaction also, there is an endothermic and exothermic process going on. Now, why does the bond breaking require energy? You have to understand that. You see, it's like this. If you've got two magnets together in physics, the north and south pole are close together, you have to do work on them to separate them. When you do work, you are basically applying energy. You're giving it energy. You're doing some work. You have to spend energy to do work. And then you separate the north and the south pole. Similarly, bonds have to be broken. There is CH. You have to separate these two magnets sticking together. So you have to give in, you have to do work, you have to give in energy. And this is that process. You are giving in energy to separate them. You're separating each of them. So this is bond breaking happening. This is endothermic. This is exothermic. Then bond forms. When the bond forms, it's like two magnets coming together, two magnets like north and south coming together. They come together. You don't have to do work. They do work. They will just reduce their energy because they are now doing work. Whatever energy they had, the north and south pole, they are working on each other. You are not doing anything. They will just, and they go into a lower energy state. That's why this is going into a lower energy state. So this is, and when they, you can actually feel two magnets coming together, they stick together, they make a noise, tuck, and that's the sound, that's the energy coming out, that's the energy coming out. So this is the whole process, and you do it by this diagram, or there's another way. The other way is you write it in the form of a reaction. CH4 plus 2O2 gives CO2 plus H2O. Now this has got some energy, so I'll call the energy of the reactants. This has got some energy, I call the energy of the products, which, if this is giving out energy, naturally the energy of the reactant according to this is more. This is the energy. I'll call this ER. Sorry, I should have used ER here. So ERI, enthalpy, there's a term you will learn in the next class, higher terms. It's called enthalpy. I'm not going to try to confuse you. So ER and EP. EP is less. So that means how energy can't be created or destroyed. It can only be transformed. So that means ER is equal to this plus this. That means the energy of the reaction is always energy of products minus energy of reactant. Obviously, if ER is, if I write this EP and in place of ER, I write EP plus heat. So this EP people can, and you get minus heat. So that's why exothermic reactions are negative. They are indicated. Either you write it here plus heat, or you write delta E. The change in energy is negative. This negative happens because you have come down. This is the delta E. This is the delta E. This depth. So this is the whole process. Endothermic is opposite. ER is less. It takes in heat. This is giving out heat to the surrounding. This is taking in heat because again it will break, again the particles will come, but the product energy will be more. So ep, energy of products, and here ep minus is going to be positive. That's why this goes up, and this is positive, this is negative. This is the energy level pathway diagram. This is the thermochemical equation, we call it. We write in whenever you have a negative term, that means it is exothermic, and whenever you have positive term, it is endothermic. So you will have to they will each most of the reactions, you will most of them you will find exo, but there will be some, like this is neutralization, this is endo exo, and there will be some which are uh, take place. So he says in an endothermic, the energy is transferred from the system, delta H is negative. In endothermic, exothermic, it is negative, and energy is transferred from the surrounding to the system, delta H. And the pathway diagram indicates the how the it proceeds. So there's a big hump in between that is not indicated here. Thus gives you this difference. The difference between the two is gives you, but there is also something called the activation energy, which in which it that also is there. I will explain. So this is the totality of